A very good morning, each and everyone. Myself, Dr. Satish Hande from the Department of Mathematics, KLS, VDIT, Alyala. In the previous session, we have studied about what do I mean by the binomial distribution and the example based on binomial distribution. Now, in the today's session, we are going to see what do I mean by Poisson distribution and the example based on Poisson distribution. So, now Poisson distribution is a limiting form of binomial distribution where n is very large, that means n tends to infinity, and p being the probability of success is very small, that means p tends to 0, so that np, that is mean of the binomial distribution, np tends to a fixed finite constant, say m, or sometimes it is denoted by mu. So where p of x is given by m raised to x e raised to minus m upon x factorial. This is the probability distribution function in case of Poisson distribution. And you can see that when p of x is called as a Poisson, the probability function, and x is called as a Poisson variate. Now for different values of x here, you can see that for values, particular value of x, we can say that the given function is here. We can get x is equal to 0, 1, 2, 3 and so on. P of x value, corresponding values, we are getting it as m square m raised to 0 e raised to minus m upon 0 factorial, m into e raised to minus m upon 1 factorial, m square into e raised to minus m upon 2 factorial and so on. If you add these values, we will get the summation of that p of x is equals to 1. So which satisfy the given condition, and mean of the Poisson distribution mu is equals to m, and the variance of the Poisson distribution will be equals to m, means the mean and variance of the Poisson distribution are same. Now we will try to solve some examples. The probability that an individual suffer by a bad reaction from a certain injection is 0.001. Using Poisson distribution, determine the probability that out of 2000 individuals, first case exactly 3, second more than 2 will suffer by bad reaction. Here p is equals to 0.001, n is equals to 2000, so mu is equals to np, which is nothing but m, and it is 2000 into 0.002, which is equals to 2, so mu is equals to 2. So Poisson distribution p of x is given by m raised to x into e raised to minus m upon x factorial, which is 2 raised to x e raised to minus 2 upon x factorial. Now we need to find out exactly 3 individuals suffered by bad reaction, that means p of 3. Wherever x is there, that we need to replace it by 3. That means it is equals to p of 3 is equals to e raised to minus 2 into 2 raised to 3 upon 3 factorial, which is equals to 0.1804. Next second, p of x greater than 2 we need to find out. That means it is equals to 1 minus p of x less than or equals to 2, which is equals to 1 minus p of 0 plus p of 1 plus p of 2, which comes around 0.3233. Now second example, in a certain factory turning out razor blades, there is a small probability of 1 by 500 for any blade to be defective. The blades are supplied in packets of 10. Use Poisson distribution to calculate the approximate number of packets containing first one no defective, second one defective, and third 2 defective blades in a consignment of 10,000 packets. Now as a solution, here if p is the probability of defective blades, that means 1 upon 500, which is 0.002. In a packet of 10, the mean number of defective blades is mu, that is mu or m is equals to np, which is nothing but 10 into 0.002, which is 0.02. Now Poisson distribution is given by p of x is equals to m raised to x e raised to minus m upon x factorial, which is e raised to minus 0.0002 into 0.02 raised to x upon x factorial. Now let f of x is equals to, because there are 10,000 packets, so we will define a function f of x as 10,000 into p of x. Also e raised to minus 0.02, which is nearly equals to 0.9802. So f of x can be written as 0.9802 into 0.02 raised to x upon x factorial. Now probability, now first one probability that no defective plate, in that it is equals to f of 0, we will get it as 9802. Next, second, probability of one defective, that is f of 1, it is 9802 into 0.02, which is 0.196. And the probability of two defective, it is f of 2 is equals to 9802 into 0.02 square upon 2 factorial, which is equals to 2, nearly equals to 2. Now third example, the number of accidents per day, it is x, we are going to take as a variable as x, as recorded in a textile industry over a period of 400 days is given. Fit a Poisson distribution for the data and calculate the theoretical frequency. That is, x is with x values are 0, 1, 2, 3, 4, 5, and corresponding f of x values are, for 0 it is 173, for 1 it is 168, for 2 it is 37, for 3 it is 18, for 4 it is 3, for 5 it is 1. Now as a solution, we have for the Poisson distribution, mean mu is equals to summation fx upon summation of f. That means summation of fx means 0 into 1.173 plus 1 into 168 plus 2 into 37 plus 3 into 18 plus 4 into 3 plus 5 into 1 divided by sum of the frequencies, which comes around 0.7825. Now the Poisson distribution is p of x is equals to m raised to x into e raised to minus m upon x factorial. Now here, now you can have p of x is equals to m raised to x e raised to minus m upon x factorial. Let f of x being, which is equals to 400 into p of x. So it is 400 into 0.7825 raised to x into e raised to minus 0.7825 upon x factorial, which comes around 182.9 into 0.7025 raised to x upon x factorial. Now the theoretical frequency are we can get by substituting x is equals to 0, 1, 2, 3, 4, 5, and they are as follows. Now first one we will get it as 183 for x is equals to 0. Next we will get it as 143, next 56, next 15, next 3, and lastly it is 0. Now fourth example, the probability of Poisson variate taking the values 3 and 4 are equal. Calculate the probability of variate taking the values 0 and 1. The Poisson distribution is given by p of x is m raised to x e raised to minus m upon x factorial. Since it is given that p of 3 is equals to p of 4, so m raised to 3 into e raised to minus m upon 3 factorial is equals to m raised to 4 e raised to minus m upon 4 factorial. This implies m is equals to 4. Now that is p of x, what you got, p of x is equals to m raised to x e raised to minus m upon x factorial. Now p of x will be equals to 4 raised to x e raised to minus 4 upon x factorial. And therefore for x is equals to 0, that means probability that x is equals to 0, it is e raised to minus 4 upon 0. X by 0 factorial, it should be 0 factorial, it is 0.0183. Next p of x is equals to 1, it is equals to 0.0732. So with this we are completing with the what do I mean by Poisson distribution, how to obtain the solution of in case of Poisson distribution, when to apply Poisson distribution. Now at the end of this session, students will understand what is Poisson distribution and how to solve the example based on Poisson distribution. Now usually Poisson distribution are fundamental concept in statistics. They are used both in theoretical level and a practical level. Some practical uses of probability distribution are to calculate confidence interval for parameters and calculate critical region of hypothesis. Now here some additional reference are given by through YouTube channel. I request each and every one of you to go through these channels. With this I conclude today's session. Thank you.